Hey everyone, Chang here and welcome to my channel. Now, we have another set of math warm-up problems. Now, once again, for those of you guys who are planning on taking the SAT, ACT, math test, math quiz, math competition, these problems are designed so that you basically are warmed up, getting ready so that when you approach those problems that actually matter, that actually count, you are already in the mindset of tackling them more logically, more organized, or at least just a more ready in general. So let's just start off with the first problem. All right, so for our first problem, we have this problem right here. Once again, these are warm-up problems. There is efficient ways, there is a non-efficient way, but that's not the point. The point is to get you started on thinking about it in a more organized, a more logical, a more mathematical sense. So how many ways can a cashier return 25 cents? For those of you guys who are not familiar with this notation, then well, I kind of dated myself. But basically, in this case, this was the original notation for cents. Now I understand it's always going to be the $.25, but that's the same thing, right? Using standard US coins. Now, standard US coins, you have your half dollars, which not applicable. But we have our quarters, our dimes, our nickels, and our pennies, which we need to use. So this problem is wonderful because guess what? It allows us to be organized in our own way. Doesn't matter as long as we are organized. So let's just start off with this. All right, first and foremost, we can have 1/4. All right, that's the easiest one for 25 cents. And of course, if you don't have that, then what do you have? You can have 2 dimes and 1 nickel. Cool. All right, well, we can keep breaking it further. 2 dimes, 5 pennies. Okay, cool. What else can we do? We can have 1 dime and 3 nickels. Okay, and then we can start breaking down the nickels. That's 1 dime, 2 nickels, and 5 pennies. And then we can have 1 dime, 1 nickel, and 10 pennies. Okay, and then we keep on going, right? We just got to make sure we don't accidentally repeat ourselves. So we have to stay organized. So that's going to be 1 dime, and how much is that? 15 pennies. Okay, that's cool. Well, this 1 dime can now be broken down into nickels as well. So let's just go with all nickels. Well, that's going to be 5 nickels. All right, that's one way to go about it. And then now we can have 4 nickels, 5 pennies. I don't know why I said 1. Probably because I was thinking about pennies. All right, and then after that, we can keep on going, right? That's 3 nickels. What is that? That's going to be 10 pennies, and then we can transfer all these numbers. That's going to be 2 nickels, and that's going to be 15 pennies. And then we're going to have 1 nickel, and that's going to be what? 20 penny. And of course, afterwards, we have our standard 25 pennies. And there it is, right? Did I miss anything? Maybe. I don't know. Check my math. But if not, we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 ways, at least from my initial attempt to solve this problem. All right, so for our next problem, greatest 3-digit number divisible by 6 and 7. Now, once again, as long as we remember our constraint based on the problem, we can go about it in any way we want. So, if you guys had a chance to think about it, go ahead. Cool, got it? All right, excellent. So, once again, greatest 3-digit number. So, basically, we're trying to get as close to 1,000, but not cross over, because guess what? 1,000 is a 4-digit number, not what we want. We want it divisible by 6 and 7, so we can just be 6 times 7. Wow, that's terrible, 6. That's 42. All right, cool. So from there, we can sort of guess any number multiplication and get it as close to 1,000 as possible. But of course, we're trying to warm up. We're trying to think about something special, something crazy. Let's see, 42 is close to 40. 40 times 30 is about 1,200. Okay, that's probably too much. So we know that whatever number we want to multiply 42 by, it has to be less than 30. What about 42 times 20? That's actually pretty good. So 42 times 20, that is 840. So we're pretty close to 1,000 already. Now, afterwards, we can be creative, or we can just, 42 times 21, 42 times 22, 42 times 23, and then we can keep on solving it that way. But of course, we want to be at least a little more creative. Let's see. So remember that every time we're multiplying by 1 more, from 20 to 21, we're just basically adding another 42. So if we're looking at this, how many more 42 can we add in there to get it close to 1000. Well, I mean, we can definitely add one more 42, or we can actually add two more 42, so that's 84. 840 plus 84, what is that? That's 924. So skipping that already, that's 924 because you added 42 twice. And that's actually even closer. So I think we can add one more, yeah. So that's going to be 966. That's 42 times 23. 42 times 24. We can make, no, we can't. Right? We have 966, and even if we add a 40, let's not say 42. 40, that's already too much because we have a 60 right here that will push us over 1000. So actually, here it is. 966 is the largest number, 3-digit number, that's divisible by 6 and 7. Alright, so hopefully everyone is somewhat warmed up, a little awake, so that problems like this one won't cause an immediate error because we are not paying careful attention. So here's the thing. This problem is actually extremely easy to make a mistake. Every time a sound wave bounces off a rock, it loses 25%. What is the percentage of the wave remaining after 4 bounces? So if we are not thinking, and we just see 25%, and then all of a sudden it bounces 4 times, every time it's losing 25%. Of course, 25 plus 25 plus 25 plus 25. That is 100%, so that means it is completely gone. That's not the case. Now, here's the thing. With a problem like this, we can approach it a lot of different ways, but the way I see it, if it's losing 25% every time it hits something, that means it's retaining how much? How much is it keeping? It is keeping 75%. So, if that's the case, after one bounce, you have 0.75 times x, whatever that wave is. But basically, this is more important. It's the fact that you only have 75% of that wave. Well, guess what? When you bounce again, this is the new wave that's getting bounced, this whole thing. So what you're going to do is you're going to do 0.75 of the 0.75x. So actually that's just going to be 0.75 squared x. Okay, that's after you bounce it twice. Well, if that's the case, this is the new one, and then you bounce it again. And of course, you have 0.75 cube x. Okay, and then afterwards you have 0.75 to the 4th power x, and that's after 4 bounce. So when you encounter a problem like this, right, although very quick to make a mistake, if we really sit down and think about it and just be creative, right, this is my way of approaching it. If you guys went about a different way and using subtraction, well, more power to you. So if we wanted to find a percentage itself, all we have to do is just multiply this guy completely out, which I kind of don't want to do because just mentally I can see, what is that? That's 0.5625 squared x, and then you got to multiply this out, which I really don't want to do. But basically at that point, if we multiply this out, then we already have our answer. Simple as that. Be very careful of these kind of problems. Alright, so there you have it. We are at the end of the video. Once again, these are math warm-up problems. Use them whenever you feel like you need to approach a situation where you have to think logically, you have to think organizationally. I guess that's the way you can say it, right? Or mathematically, it doesn't matter, right? The whole point is to get you warmed up. Each and every one of them have many different ways of approaching. And you can spend your time trying to find out all the different ways of approaching it. And maybe some of you guys will. But that's the idea of these problems. Efficient, non-efficient, doesn't matter, right? The point is that it gets you warmed up and ready to go. So whatever situation, scenarios you have to encounter now, go kick that exam's ass, go conquer the competition. Good luck. Thank you for watching this video. Please like, comment, and subscribe if you haven't done so already. See you in the next video.